Hello, everybody. So this is part two of plotting and visualizing data in our part one. Sorry, I know that's confusing. We try and chop it up a little bit so there's not like super long tutorials in class or on video. So hopefully if you're watching this, you already watched Tara's video and looked at the materials about scatter plots and box plots. We are just building on that in the part in this video for part two. We're going to play with time series data, but there's nothing sort of fundamentally time series about this. Really, what we're doing is we are going from cases where we just have like X and Y values to cases where we have X and Y values that are mapped across some sort of groups or time periods or something where we want to like draw lines and connections between them. And that'll make more sense when you kind of see what we have to do to make those work in a slightly different way. So the first thing I'm going to do, I'm going to load the tidyverse. Lots of messages there. We're not going to worry about it. And I'm going to create a data frame called surveys complete, just like you did for part one. I'm going to read underscore CSV in the data subdirectory, portal data join.csv. And then I'm going to make one pipe to filter. And then I'm going to use that complete cases command. That can be dangerous, but in this case, let's just do it. Put the dot inside because we want to sort of signify like we want to call complete cases on the piped in data frame. If you run that, you end up with about 30,676 rows exactly. So the first thing we are going to do is make a scatter plot, which is not quite in the tutorial. I'll show you why in a second, of yearly counts of species ID and for each year, the number of times each species was observed per year. So let's call that yearly counts. And that is going to be based on surveys complete. And then we are going to count by year and species ID. Now, you might not have seen the count function before. If you look in the help file, the deployer tells you it's just a quick way of counting how many times you see observations that have a particular combination of variables. And in fact, yearly counts, it produces the identical result of calling surveys complete pipe group by year species ID piped to tally. And so both of these, in fact, if we call head on the first one, you see we get three columns, year, species ID, and N. And if we call head on the second approach to doing that, so you can see we also get year, species ID, and N. And I believe because it sorts by year and then species ID, yeah, those values are completely identical. So I'm going to make a note in this script. Two different ways of doing the same thing. I always like to highlight that when we show you some new bit of code you haven't learned before that maybe you knew how to do it with old code. In any case, let's make that yearly counts variable or data frame. Yearly counts is surveys underscore complete. Boy, I'm having trouble typing today. And pipe to count year species ID. Ah, another typo. And you can double check that looks right. Yep, that looks like what we want. Three columns, year, species ID, and N. You recall when we introduced you to ggplot, ggplot eats data in long format. So you could imagine pivoting this summary data frame into wide format with years on as rows and species IDs as columns, and then N values sort of mapped into the XY matrix. ggplot doesn't like working with that at all. It wants long data where each variable is only one column. And if you think about it in pivot wider, you end up with multiple columns for a given variable, species count. So we want to keep that long format. First thing we're going to do, let's just make a quick scatter plot. ggplot data equals yearly counts. Mapping equals AES, parentheses, X equals year. In general, when we're doing time series, we tend to want to keep the time variable, whatever that variable is, on the X-axis. X equals year, Y equals N. Going to plus sign. So remember in ggplot, we use pluses to string objects together, not the piping sign. The reason is we're not feeding things beyond to the next thing, we are creating some sort of ggplot object with the initial call, and then we're adding layers to it. And so that's an easy way to remember you need to use that plus sign. In this case, let's add a points layer. Oh, geom points is not a function. Geom point is. So now we have scatter plot. It's a bunch of dots that are stacked up by year, which is just the count of each species observed each year. So we could turn that into a line plot. ggplot data equals yearly counts. Mapping equals AES, X equals year, Y equals N. Plus sign, geom line. Oh, that looks pretty bad. This looks like what you see in your tutorial. So what's going on there? Look at this dot plot again, the scatter plot. Look at the lines again. So you can see this line plot is working. It's tracing through all the dots. What it's doing is it's starting at the first observation for each year. And in this case, since it's sorted by from highest to lowest, it starts at the highest value for like 1974. It goes straight down through all the values for 1974, and then, or whatever year that is, I don't know, and then hops up to the next year, and it keeps repeating that. It's like it goes all the way down through 1980, and then hops up to 1981 and goes all the way down through 1981. And so there's actually no observations in those like angular segments. All the observations are in the vertical lines. We're just kind of drawing between them. And so what we're seeing as some sort of series is not, it's just lumping all the values together. So in this case, what we'd actually want to do is add a grouping variable. And the way we're going to do that is we are going to tell R in the aesthetic call group equals, and in this case, species ID. So instead of drawing one line through all of the year count observations, we want to draw a line separately for each species through each year and count observation for that species. So now if you draw this, and you see an example of this in the tutorial as well, it looks like real data. That's cool. It's a start. But we now can't really tell what's going on, like which species is which here. So you might think, okay, let's add color. ggplot data equals yearly counts, mapping equals AES, X equals year, Y equals N, group equals species ID, and color equals species ID. Now, if you call color, you don't actually need to call the group by function. So I'm our settings. So I'm going to delete that because the color acts as a group. Geom line. And if you run that, oh, I did something wrong. Geom line. Oh, I just called it again. Oh, what do I got here? Oh, I forgot to close off my parenthesis. The AES parenthesis, and then I need to close off the ggplot parenthesis. Okay, so this should work. All right, it works kind of, but in your graphical window, it looks pretty bad because you have about a bajillion species observations and like really tightly gradated like color combos here, right? There's like 6 different shades of green going on. Impossible to say like, oh yes, where's the NL line and find it on there. So this makes the lines do what they should, but it's still not like an intelligible plot, which brings us to the next feature we want to highlight, which is faceting. So instead of altering the color by species, we can give each species its own separate plot and then have the title of each plot show that species. Show you what I mean by that. ggplot data equals yearly count. Mapping equals AES, X equals year, Y equals N. We're just going to leave the year and the count. We're not going to add anything else. I'm going to make the plus sign, and now I'm going to call geom line. Let's make sure this works. All right, this is our bad old line again. Now I'm going to call facet wrap. So I'm going to say plus, next line, facet, F-A-C-E-T, wrap. I'm going to open and close the parenthesis. Now I'm going to write a function, an open-ended function. And so what I'm going to say is I want to facet by the species ID variable. So if you've learned how to do regression in R, the function, I guess you call it function nomenclature, like way you program in functions in R, you've probably already learned. Things like y tilde x tells our regress y on x. Facet wrapping uses the same syntax. That's the word I was looking for. Uses the same syntax for writing up functions, because essentially what you're saying is I want this plot to vary by species ID. Let's check it out. So it does not look nice in my plot window. I get like giant labels and tiny plots. So you could imagine playing with that. But functionally, what we end up with is a separate plot for each species ID. So if you wanted to actually be able to tell, like how many species are here, what's going on, when were they observed, this type of graphic would get you there. You could do a couple things I want to highlight that improve it even more. So the first thing is facet wrapping has a couple special settings. One, you can set the number of rows or columns. So if I wanted 4 columns instead of 5, if I call n row equals 5, or four rows instead of 5, or vice versa, now we have 4 rows and 6 columns for each case. Or if I can do the opposite, n col equals 4, and now I get 4 columns and 6 rows. Not necessarily useful. I can also adjust the scale. So if you look at each of these facets, you can see that it's kind of tough to see what's going on, because some animals are observed a lot and some are observed very little, and then some are only observed in certain years and not others. So this gives us like a really good image of the most frequent animals, and it gives us a really good image of like the temporal distribution of when different collections are happening. But let's say if you were more interested in like changes within a particular species over time, you could say scales equals, and now there's 4 options. There's fixed, which is the default, which is same x and y for every faceted panel. There's free underscore x or free underscore y, which lets one vary and not the other. Or there's free, and we're going to try that. Scales equals free. And if you run scales equals free, the plot looks a lot more dynamic. It's still not showing up super well, because it only plots the time window that's observed for each species, and it lets the scale vary as a function of the n values for that species. And so the axes are all different, but you see more like within plot fluctuation. So that's not necessarily right, just to sort of show there's different ways of getting at all that. Once you sort of mastered this stuff, there's all sorts of like theme calls and adjustments you can make to text size and border width and all the things you need to make a plot actually look like professional and be able to send it to a journal. We make all of our journal ready plots in R at this point. We don't do any touch up outside of that, but it does take a bit of practice and learning. But in any case, hopefully this gives you sort of at least a vision of how you can dip your toe into time series and making multiple panels. Again, though, remember that faceting is not limited to time series plots or years. You could use it for just about anything to highlight. It essentially allows you to add a third dimension to your graph. All right, let us know if you have any questions. Look forward to talking more about this in class. Thank you.